When Ubisoft released the remake of Assassin's Creed 4 Black Flag in July 2026, many expected the studio to simply build on the original game. Instead, game director Richard Knight revealed that the team couldn't use the 2013 codebase at all, because it was no longer suitable for a modern game, forcing Ubisoft Singapore to rebuild everything from the ground up. It's a striking example of how quickly game development moves. If one of the world's biggest publishers can no longer rely on the source code of one of its most successful titles after just 13 years, smaller studios often face the same problem even sooner. Open the archive of a decades-old game, and you're likely to find obsolete storage formats, unfinished builds, and folders with no meaningful documentation, making reconstruction a major part of modern game development. Westwood Studios built Blade Runner in 1997 with a voxel engine years ahead of the market. Then Electronic Arts bought the studio and moved it from Las Vegas to Los Angeles, and the source code did not survive this move. Konami went further with Silent Hill 2. After the game shipped, somebody decided the build data no longer earned its storage costs and wiped it. Blizzard North lost most of Diablo II a third way. One of the founders described a corrupted master file, with assets surviving only because employees had taken copies home. Nobody plans for this, because by the time it becomes a problem, the studio may already be closed, the servers decommissioned, and the original developers long gone. A project archived on a tape format from 2001 might require hardware that disappeared years ago, while the engineers who knew where everything was stored have moved on to other companies, leaving future teams with little more than a collection of textures. Konami handed Hijinks Studios everything it still had for Silent Hill 2 and 3. Producer Tom Hewlett later described what showed up, source code that wasn't the final release version of the games. The team received a build from somewhere before launch. Every bug the original developers found and killed in their last months of work came back, with no record of how they fixed it. Hijinks spent debug time chasing problems that had already been solved once by people who left years earlier. Textures and audio had to come out of the compiled game because the source assets were gone too. Pull a texture from a shipped executable and you get the compressed, platform-specific version, not the artist's file. You inherit every compromise the PlayStation 2 forced in 2001, and then you upscale it. The HD collection took more than 2 years. Building the original Silent Hill 2 took about the same. Players called the result a mess. Konami never shipped a full fix, and the studio's real problem never made it into a single review. Somebody asked them to remaster a game that no longer existed in a form anyone could remaster. Losing the original source code doesn't necessarily mean a game is gone forever, but it completely changes the kind of expertise a studio needs to bring it back. Nightdive Studios has built its entire business around solving exactly that problem, with engineers who take a shipped executable, analyze how it behaves, reverse engineer the binary, and gradually recreate the game's logic inside the company's own Kex engine. That's the approach that brought Blade Runner back, with Nightdive's Larry Cooperman explaining that the team had to painstakingly reverse engineer the original code before it could be adapted to a modern platform. That workflow has already produced remasters of games like Turok, System Shock, Doom 64, Star Wars, Dark Forces, Blood, and Power Slave, with Thief, the Dark Project, next in line. In many cases, however, rebuilding the renderer is only part of the challenge, because recovering the game's logic can be far more difficult. The Witcher, for example, was released in 2007 on BioWare's Aurora engine using NW script and Lua compiled into bytecode, a process that strips away variable names and other context, leaving developers with instructions but little indication of the original intent. Rather than untangling all of that by hand, CD Projekt Red chose to have Fool's Theory rebuild the game from scratch in Unreal Engine 5. There's an approach that avoids rebuilding old code altogether. Instead of replacing it, developers simply keep it running beneath a modern presentation layer. That's exactly what Blizzard did with Diablo II, Resurrected, where the original 2000 game engine still handles every calculation and every piece of gameplay logic, while a completely new 3D renderer sits on top. As franchise head Rod Ferguson explained, the original game is still there under the surface, and with the press of a button, players can even switch back to the classic sprites. Keeping the original code also means preserving decades-old quirks, some of which turned out to be features rather than bugs. Designer Rob Gallerani, for example, noticed that Baal's clone displayed its health bar 1 pixel lower than the real Baal's and initially assumed it was an error, only to discover old forum posts revealing that players had relied on that single pixel difference to identify the real boss. Rather than fixing it, the team intentionally recreated the behavior in the remaster. Ubisoft chose a very different approach with Assassin's Creed IV. Black Flag, rebuilding the game from the ground up instead of relying on the original code. According to game director Richard Knight, the remake is essentially a brand new game, combining systems carried over from Assassin's Creed Shadows with newly rebuilt lighting, weather, parkour, and even story content that never existed in the 2013 release. Although rebuilding a game is far more expensive than producing a traditional remaster, it also eliminates the need to maintain or debug decades-old code that few developers can still understand. CD Projekt Red reached the same conclusion with The Witcher, replacing the old Aurora engine with Unreal Engine 5 and having Fool's Theory create new systems instead of trying to decode compiled bytecode. In the end, every studio restoring an old game faces the same decision: reverse engineer the original, keep the old engine running beneath modern technology, or rebuild everything from scratch. Games rarely disappear because players stop caring about them. They disappear because the tools and technology they were built with eventually become obsolete. Every remaster, remake, or console port begins with the same question: how much of the original game can still be used, and what has to be rebuilt from scratch? That's exactly how Kevuru Games approaches every porting project, starting with a full technical audit of the existing codebase and engine before identifying bottlenecks, refactoring outdated systems, and migrating to newer engine versions whenever the target platform requires it. Our console port of Poppy Playtime Chapter 2, for example, involved upgrading the project from Unreal Engine 4.27 to 5.4, rebuilding the lighting pipeline, reworking shaders, fixing physics issues introduced by the migration, and ultimately shipping certified versions across 4 consoles. For more than 13 years, we've been helping games outlive the technology they were originally built for.